Hello, this is Vidura. Here's some update from the modular switching device. I have here my power switch modules, 4 IGBTs for an H bridge and 2 more with IR-F250 MOSFETs. Then the power supply for the driver. My first module, first PWM module, and here the second one, the new one. Some of the features. Okay, we can do an analogous adjustment for coarse and fine for the frequency by the clock from the processor, and 2 coarse steps to make a broader frequency spectrum possible. Then we have for each channel an individual duty cycle adjustment, analogous, and we have a common duty cycle adjustment for both PWM channels. Then we have an adjustment for the phase shift between the 2 channels, which is the only part which is digitally timed. I have a 5-bit resolution here. That means there are 32 steps available of frequency shifting between the 2 phases. Anyway, a trick can be used to make the phase shift difference analogous also. This will be covered later. Then we have a fine-tuning for each channel for the duty cycle. We have 2 broad ranges for each duty cycle for each channel. We have 2 different complementary output modes setable by the dip switch, and we have 4 frequency ranges setable by the internal PWM clock of the processor, also with the dip switches. Now, then another feature I forgot is the connector for slave devices. There is a clock output from the processor and a synchron pulse, which can be used to synchronize another module or various other modules to run all synchronized by the same clock source. This can be used to add additional phases as needed. There is also 1 pin for an independent CCP module, which is a common digital PWM module integrated in the processor, which is not used for the moment, but it will be available to connect or to program if anyone has the skills to program these devices. So we will see here as an example, we are in the complementary output mode, which means the phases are always 180 degrees shifted. This is typically used to drive H bridge. Here I can adjust analogous the duty cycle to one or to the other side. You can see I can shift the frequency. Okay, now we switch to the normal PWM mode, which means we can individually shift the duty cycle for each channel. You see, for each channel individually. Then we have the phase shifting, which is in 32 steps, a 5-bit value, which is digital. And then we have the other potentiometer, which regulates the duty cycle for both channels. We'll make it a little bit bigger so we can see it better. Okay, see? Yeah, okay, that's it for the moment. I will give more detailed information about this. We'll prepare tutorial videos and will also edit the document so it's easier to translate for those who do not speak English. Thanks for watching.